So a statistics professor knows from experience the final grades of his Stats 213 class are normally distributed. Okay, they have that bell shape. The middle, the average, is typically 70%, and the standard deviation, say, 10%. So what is the probability of the following? Let's say, what's the probability of a randomly selected student having at least 90%? Okay, so at least 90, at least means less than or equal to 90. So what's the probability a student has at least 90%? I've drawn it out here. The middle is 70 in terms of x, and I'm interested in this value of 90. I can convert these into the z-score. Okay, of course, the middle always converts to 0. And to convert this 90, it would be this value 90, subtract the middle, divided by the standard deviation, which happens to be 2. Okay, so two different ways to write this. I can say the probability at least 90, sorry, not less than or equal to 90, but greater than or equal to 90. I want to know what the probability of this tail is. Okay, so that would be written this way. X is greater than 90. Okay, here I'm in the X scale, which we've seen is the same thing as converting this X scale into a Z. In this case, the Z is 2. So the probability of X being greater than 90 is the same as the probability of Z being greater than 2. Okay, so here then, you've seen numerous ways to calculate this. One way then, if I've done the z-scores, that means the mean is 0 and the spread is 1. Standardized scale. I've got a cumulative probability. Okay, so here I'm going to look up the z value 2. I get the answer is 97 or 98%-ish. Okay, so from here to this point is 97%, 98-ish%. So 1 minus that will give me this tail probability of having at least. Okay, the other trick that you can do, of course, is instead of using positive 2, if I use the mirror image of positive 2 and put in negative 2, really what I get then is some value around here. It's the mirror image of this tail, and I don't have to do the 1 minus. Okay, so I've got the probability of that is something like 2%. B, if the professor in question sets his C range to be in between 55 and 70, then what is the probability of getting any sort of C? So here, in between 55 and 70, this shaded area right here is the probability we're looking for. Again, how to write that? X is in between 55 and 70. We can convert this 55 into a z-score if you like. It ends up being negative 1.5. So X is in between 55 and 70, but Z is in between negative 1.5, and here this z-score of 70 is known to be 0. Okay, so to find these two cumulative areas, maybe I'll just write them down. This is the negative 1.5, and here we've got 0. I'll look them both up at the same time. Calc probability distribution of the normal. Here I want the cumulative probabilities of the values that I've put into column 1. Okay, I've used Z values, so the middle is 0, the spread is 1. Okay, these are the two cumulative probabilities. Okay, so cumulative 0 is 50%, cumulative negative 1.5 here is about 7%. If you take the difference of those two, we'll find the probability of getting some sort of a C of a randomly selected individual is about 43%. Finally, the top 15% of final grades will earn at least a B+. So what is the probability, or sorry, what is the percentage that a student must obtain in order to get a B+? So where does B+ live? Okay, so here the top 15%, top means here the greater than side is the 15%. So here this is the greater than side is 15%, the top 15%. And I can split this up into the other side. So 100% minus 15 is going to give me 85%. Okay, so here the percentile is the 85th percentile. Percentile is always less than or equal to. So another way of saying the top 15% is saying the 85th percentile. Okay, we've seen a few of these problems. We've got 85% of the data on this side, on the left side of this point. We have the area, we want the point. Okay, so a few different ways you can do this. Okay, so here I want the inverse cumulative probability. If I'm going to use a z-score, the middle is 0, the spread is 1. Here I'm talking about the 85th percentile, so 0.85. Okay, so then when the value is when the area is 0.85, the value is 1.03. Okay, so this is the z-score. I can then use this formula to solve for x. So here I put in this value, this is z. X is what I don't know, it's what I'm solving for. Mu is going to be 70, standard deviation is 10. Use my algebra, solve for x, I get 80.36. The other way of doing it, so you need to know both ways, don't just focus on one way, okay? Just because I'm doing this and it seems easier, it's not only the way that you need to do it, you need to know both ways. Okay, so here I can also say if the mean was 70 and the spread was 10, then the inverse of 85% or the 85th percentile is 80.3643.